In today's note, we're going to look at solving multi-step equations. So this is going to be a little bit different from the 1- and 2-step equations that we did in the previous note, but multi-step, basically all that means, so a multi-step equation means variables such as x on both sides. So all that means is that we have variables such as x on both sides of the equal sign. So if we look at our example, in A, solve 3x plus 9 equals negative 2x minus 11. We can see that I have x on both sides of the equation. So what we have to do in this case is we need to get, I'll put this on the side here, get x on one side. So basically, because we have the variables on both sides, if we're trying to solve for x, we need to get the x values on one side. So if I look at this, I need to get the x's on one side. So let's say I want to get rid of this negative 2x on this side. I don't want it over here. I would need all the x's on one side. So same idea in the past. In order to get rid of this minus 2x, I need to add 2x, and I'm going to do the same thing to the other side. I'm going to add it specifically to the 3x because those are like terms, or they're similar. So in this case, I have 5x plus 9 equals this negative 2x plus 2x cancels each other out, and it equals 11. And that's all that's left. Now what we've done is we've created a two-step equation. Right, so very similar to what we've done in the past notes. Now we need to get x by itself, so that's our next step. We need to isolate x. So I'm going to go through the same steps as in the previous notes. To get x by itself, I'm going to start with this separate term, get rid of this plus 9 by subtracting 9. Need to subtract 9 from both sides. 5x equals negative 20. In order to get rid of, and then these two cancel out. In order to get rid of the 5, I need to divide by 5 because I'm multiplying it with the x on top. Do the same thing to the other side. Divide by 5. One side it cancels out, and I'm left with x equals negative 4. That's my final answer. B, I want to check my solution. So if I'm going to check my solution, I have the 3x plus 9 equals negative 2x minus 11. So again, this is my original equation. To check my solution, what I need to do, I need to sub in my answer for x. So I'm going to sub in my answer for x. I found that the answer was negative 4, so let's see if that's the right answer. Everywhere I see an x, I'm going to sub in negative 4. So I have negative 12 plus 9 equals positive 8 minus 11. I get negative 3 equals negative 3. It's the exact same number, so that means my solution is correct because negative 3 does equal negative 3. Example 2 is the same idea except there's one extra step, right? One extra step, which what we can see is, I'll write an example on the side, 2 times 3x minus 2. This is an example of distributive property. And what the distributive property is because I'm multiplying 2 by everything in the bracket, that 2 needs to be multiplied to both parts. So That means in both sides of my equation, this 2 needs to be multiplied to both parts, and on the other side, the 4 needs to be multiplied to both parts. So let's simplify this. So 2 times 3x, I'm going to write everything out fully. So 2 times 3x minus 2 times 2 equals 4 times x minus 4 times 5. Now I'm going to simplify it. 2 times 3x is 6x minus 2 times 2, which is 4, equals 4x minus 4 times 5, which is 20. Now we're at a step that's very similar to what we just did. So so we need to get our x's to one side. I'm going to say let's get rid of the 4x's over here. So to get rid of plus 4x's, I need to minus 4x. Do the same thing to the other side. Again, I'm only subtracting them from the 6x because of our similarities or our like terms. 6x minus 4x, 2x minus 4 equals negative 20. And now we're down to a two-step equation. To get the x by itself, to get rid of minus 4, I need to add 4. Do the same thing to both sides. I'm left with 2x equals negative 16, because these minus 4 and plus 4 is canceled out. To get rid of the x, because it's 2 times x, I need to divide by 2. I can divide by 2 on both sides. One side they'll cancel out, and I'm left with x is equal to negative 8. Because of negative 16 divided by 2. Again, I want to check my answer, so I need to rewrite my equation. 2 times 3x minus 2 equals 4x, or 4 times x minus 5. And everywhere I see an x, I'm going to replace it with the answer I got, which in this case is minus 8. So 2 times 3 times negative 8 minus 2 equals 4 times negative 8 minus 5. And now I'm going to go through and solve. So this is where BEDMAS becomes very handy. Right? Order of operations, brackets, exponents, division or multiplication, addition or subtraction. So I'm going to simplify my brackets first. So 2 times, we have 3 times negative 8, which is negative 24 minus 2, equals 4 times negative 8 minus 5, negative 13. I still have stuff to simplify on the left side. 2 times negative 26. On the other side, I can do the 4 times the negative 13, where I get negative 52. 2 times negative 26 is negative 52. So I get the same thing on both sides. So that means my answer of negative 8 is correct. So again, looking at multi-step equations, we have to look at a couple things. Remember, multi-step means that I have a variable or a letter on both sides of the equation. I want to get them to one side. We may come across situations where we have something called the distributive property, which we see again up here at the top in red. We need to multiply the number outside the bracket to everything on the inside.